back to my YouTube channel. Today we'll be dealing with Mechanotechnics. This is a flywheels. We've given example one says a flywheel has a mass of 500 kg and a radius of curvature of 200 millimeters. Says calculate number A the moment of inertia of the flywheel. Number B the kinetic energy stored in the flywheel when rotating at 2.75 rests per minute. All right, we should calculate the moment of inertia. The formula to calculate the moment of inertia, guys, the moment of inertia, it is given by this formula. The moment of inertia is denoted by I, whereby is calculated by, this will be equals to, it is a mass, it will be the mass of that. What's wrong with this pen now? It's a mass multiplied by the radius of curvature, okay, squared like this. All right, so we have the mass, isn't it, which was 500, the radius of curvature, okay, the radius of curvature is 200 to divide by 1000 will be 0.1.2. So this is 0.2. You square this, then our moment of inertia will be what? 200 is measured in kgs per watt meter squared. So this is how you calculate the moment of inertia using, this is the formula, guys. Then B says the kinetic energy stored in the flywheel rotates. Of that, how do we calculate the kinetic energy? EK will be given by 1/2 multiplied by moment of what of inertia. Multiply this by moment of inertia, also by angular acceleration, angular velocity, watt squared. You must know this. So we have this 1/2 the moment of inertia. It is, what is the moment of inertia? It is 20, is the one that we've calculated there. Now what about the angular? The angular is given by 2 pi n. Remember our n we are given there will have 2 pi. What is n? N, it was 2.75. remember all these is supposed to square, since we have the square there. Our speed is this, guys, 2.75, because given in rest per seconds. This will be equals, we punch that, will be 2.986 obvious kilojoules. So this is what we have there. All right, so example 2, we've given a flywheel. Sorry about that. We have given a flywheel there. Okay, given the flywheel has a mass of 220 kg, radius of curvature 175 millimeters. Is calculate the kinetic energy required of the for a speed of that. Okay, so guys, we are used to now A, we know the formula for kinetic. EK, we said it's what, it's 1/2 multiplied by the moment of inertia, isn't it? Moment of inertia multiplied by what? By angular velocity squared. So we have 1/2 the moment of inertia. Remember, the moment of inertia by itself is equal to mass multiplied by radius of curvature squared. So the mass there, are we given the mass? The mass is 220. Here I have 220 multiply this by radius of curvature, which is 775 millimeter. This is the same as 0,175. Remember, we square this, multiply by the angular. The angular is the same as 2 pi what n. What is n now? The n is 3.5. So we have 3.5 like this here. All right, but now we're supposed to square all of these. Yeah, all right, supposed to square all of these because this is squared there. Square all of that. This will be ek. You simply equals to 1,63 kilojoules. Alright, B says the uniform torque required to make 1.27 revolution. The uniform torque. Okay, guys, uniform torque will calculate if you have given the NA, the kinetic energy. There's this formula. Remember, this is the same as angular motion. This formula says EK is equals to torque multiplied by what? By the angle 10, guys. The angle 10. All right, still remember that. So if you make torque the subject, you'll have that. This will be EK divided by that angle 10. The angle 10. All right, whereby this is 2 pi multiplied by the speed multiplied by, let me check what we have, the revolution there, revs. So we have EK, which was 16 would be with 1.63 kilojoules times 10 to the power of what of 3 divided by 2 pi. The angle say it is 10, 1.25. They have given what number of it's 1.25 revolution, 1.25 there revolutions. So our torque there will be 207, 5 measured in Newton meter. All right, so what else do we have? Says the time required to make 3.5 rests per seconds from rest. Now this is an average from, with two things from rest. Initially one is 0. All right, so this is an average. See, those things are average. We want the time. So guys, time we know it's given by, will be the number, since we've given the number of revs divided by average speed. So we have average speed, number of revs is 1.25 divide the average is from initial is 0, the final plus final, divide by 2. So this will be equals to what? 0.7 seconds. So this is what we have. All right, number 3 says in electrical motor initially, you see this will be initially, that means initially that's 0, it rotates rests per seconds, rotate 18 rests per seconds after 5 seconds with the uniform acceleration. Says the angular acceleration. So we have the average speed there, guys. We have two velocities initial in that, so we'll have the average. So since we'll have the average, we want the angular acceleration, so we have their formulas. The one that we know, the motion formulas. Number A, we have W2 W1, but this is supposed to be average plus, what is this, angular acceleration multiplied by time. All right, so this is at what? Its initially will be 0. What do I want actually? We want the angular acceleration. If I divide by, if I will make angular the subject, I'll have this to be W2 minus W1 divided by time. All right. Okay, this, remember angle is given by 2 pi n. So we have there 2 pi n 2. Obvious, this must be final, minus 2 pi n1 divided by t. All right, 2 pi, this final one, the revolution 2 is what? It's 18. So we'll have here multiplied by 18 minus 2 pi. It's from rest, was from rest initially, it's at 0. The time we've given 5 seconds. So since this was an average thing, this will be what? 8,87 rads per seconds. So my second squared, oh, rads per second squared. Since this is an acceleration, angular acceleration, B, we should determine what? B, the angle 10 through the theta in radians. We want the angle theta will be equals to what? It's the same as displacement. This is 1/2. The same as displacement. By displacement, it's 1/2. Angular acceleration t squared plus 2 angular velocity 1 multiplied by time. So we have 1/2 angular. We had it there, it was 22 22 uh, is this correct? It's wrong. Just punch this. Maybe is very wrong. This one is wrong. It is wrong there. We have 5 seconds. This must be 22,65 rads per second squared. So our angular here will be 22,65. Alright, the time it was 5 seconds squared plus initial velocity. This it was what, 0. So this is same as 0. This whole thing will be 0. Then our angular displacement will be 1 over 2, 22, 22,65 multiplied by 5 squared. Punching this, we have our displacement as 282,8. This will be in radians. So to be in degree, obviously you divide this by 2 pi. We know that to be in revelation, in ref, divide this by 2 pi. 28,8 divided by 2 pi is the same as divide by 360. This will be 45 revs. If you want the number of revs, so will be that. Alright, so number 4, we have a flywheel. It is uniformly accelerated from rest to 12 rests per second in 8.5 seconds. The diameter of the flywheel is 1.6 m. Calculate the angular acceleration of the flywheel. This is the average. So we'll use the same formula, guys. The average to calculate angular is the same, will be W2 minus W1 divided by time. This is the same as 2 pi n2 minus 2 pi n1 divided by time. Here we have 2 pi. Our final one is what? Rev is 12. So we have here 12 minus 2 pi. This it was from initially. That it means it started at 0. Then the time there, it's 8.5. 8.5. So punching this, getting that angular acceleration, obtain this to be 8,87 rads per second squared. Alright, then number B, what is needed? The linear velocity of the flywheel. Okay, the linear velocity, guys, is supposed to be equals to what? To angular multiplied by r. Alright, convecting from that, returning back. We are returning back. We're supposed to use this formula. Let me check B. B says, okay, the angle. Number B, the angle 10 through radians reaching 12 rests per second. Okay. Number B, we have to find the displacement. It's simply just a displacement. We know displacement is 1 over 2 at squared, angular like plus W1 T 1 over 2 angular, it was 8.87 multiplied by time, it's 8.5 squared. This was initially at 0, so this will simply equals to 0, will affect everything. So if we punch this, have our angular displacement to be 32.4. This measured in radians. So number C, you have to find linear velocity. Linear velocity will be linear velocity of the flywheel multiplied by the radius of the flywheel. So this is the same as 2 pi, n is what, multiplied by 12 times 0.8 of the radius. Remember, we've given the diameter to be 1.6, we divide by 2, then this will be 60.32 meters per second is measured in that. So D, we want the tangential acceleration. It's the same as linear velocity. Linear acceleration, we know that plus AT. We want A is V minus U divided by T. Using this formula, we'll have that our stuff here, velocity is 60.32 minus initially 1. Initial, I think it was what? It was 0. Here we have 0 divided by time, which was 8.5. So acceleration will be 7.09. All right. Then we want the centripetal acceleration. Centripetal acceleration is given by what? Centripetal acceleration is given by v squared divided by radius. Obviously, this is 60.32 divided by radius, which is 0.8. This will be 4548 meters per second squared. Centripetal acceleration. Then yeah, this is an centripetal this will end here. So guys, thank you for watching. May you kindly subscribe to my YouTube channel and click the notification button so that you'll be notified whenever I post a new videos.